Hello dear students, welcome you all. How is everyone? So we are going to start revision through question series. Tell me if everyone is able to hear my voice. Are you able to hear my voice? So welcome you all to Wallah English channel. On this channel today we are going to discuss structural analysis questions which will be very important for your exam point of view. So all the students who are studying, who are giving GATE examination this year, for them this session is going to be very important, as we will be discussing some questions related to structural analysis, and we'll try to cover all the concepts of structural analysis in this session. So don't miss this session, watch till the end, and if there is any doubt or if there some portion that you missed to revise, here you will be able to revise also, and you will recall the important formulas also. So without wasting any time, let us begin the session. Let us start the session. So first question. Anyone online? If you are online, try to answer this. So first question related to static indeterminacy. So you have to identify whether this truss is statically determinate or statically indeterminate, stable or it is unstable. So let me put on the timer and let me give you 30 seconds timer for this question. So try to answer within 30 seconds. 30 seconds are more than enough for this question. Okay, so if we try to find out degree of static indeterminacy, what is the formula for degree of static indeterminacy for truss? So degree of static indeterminacy formula will be equal to number of unknowns minus number of equations. So each member is having how many unknowns? Each and every member in a truss is having one unknown. हर एक मेंबर में एक अननोन होगा. In each and every member there will be only one unknown. So number of unknowns in each member is number of members. Okay, so total number of members we will count, plus external support reactions M plus RE external support reactions. So these are the number of unknowns. How much will be the equilibrium equations? So at each and every joint we will be getting two equilibrium equations, summation fx equal to 0, summation fy equal to 0. So minus number of equilibrium equations will be how much? 2j. Number of joints is j. Okay, so now we'll calculate number of members. So let us calculate number of members. This is one member, 2, 3, 4, 5, 6. This member is 7th, this member is 8th, and this back member, this is 9. So there are 9 members. So number of members is 9 plus external support reactions. Here are 2 external support reaction. Here is 1 external support reaction. So 2 plus 1 will be getting 3 external support reactions minus 2 into, let us see how many joints are there. So here is 1 joint, 2, 3, 4, 5, 6. Okay, so there are 6 number of joints. So 2 into 6. So 9 plus 3, 12, minus 2 into 6, 12. That will be equal to 0. So degree of static indeterminacy here in this case will be 0. That means this is determinate. Okay, so option A is correct. It is determinate. Now can you tell me if it is stable or unstable? If I apply loading, I cannot see anywhere that it will undergo rigid body or rigid body deformations. It will not undergo. So therefore this is stable also. So this is MSQ type of question. It will be determinate and stable. So correct answer will be option A and C. Sir, I am not watching the middle screen. Middle screen? You are not watching middle screen. You are not able to watch middle portion of screen. Oh, because of reflection of light. If okay, just a minute, let me try to solve this issue. if you are not able to see because of reflection of the screen, let me try to increase the brightness. Just a minute, okay? Okay, let me increase the brightness of the screen. Night light is off. Okay. So now, is it better? I think it will be better now. Okay. If you are not still not able to see, then tell me again. Okay, this is the next question, question number 2. So I hope you understood this question. This question was very easy. No, not any difficulty in this question should arise. Next, this is the question. So try to answer this question. You have to draw the influence line for the force in member CD. So for this question, I am not giving you any options. Okay. For this question, I am not giving you any options. Why? Because with options you can get idea. Okay, we are here to understand the concepts. Okay, so try to solve it yourself. For this member CD, we want to find out the influence line diagram for this member CD. Okay, how much time do you need? Okay, I'll give you 1 more minute. Okay, apart from whatever time you have got, I'll give you 1 more minute. So try to draw the influence line diagram for member CD. It's not very difficult. In fact, it's easy. Shall I start? Okay. So now I'll start discussing. So if you want to draw the influence line diagram for member CD, first of all you have to, what we will do? See, for member CD, we want to find out only for one member. We will use method of sections. Okay. So we are going to use method of sections in this case, and the section that I'm going to cut, is section this here. Here I'll cut the section. Okay, so I'll be cutting 3 members here: KJ, CJ, and CD. Okay, now if I want to find out force in member CD, I have to choose such that forces in these 2 members should not come into picture. So what I will do summation of moment about point J equal to 0. If I do summation of moment about point J equal to 0, then what will happen? Force along this member, moment will be 0. Force along this member, because of this force, also moment will be 0 about J. Okay, so here I will be having vertical reaction at A, and let us say this is horizontal reaction at A. There will be no horizontal reaction. Okay, summation fx equal to 0, there will be no horizontal reaction. First of all, we will try to calculate VA. Okay, how to calculate VA? So to calculate VA, summation of moment about G equal to 0, I'll do. So summation of moment about G equal to 0. So what I'll do, when I want to draw the influence line diagram, there is unit load moving. So let us say this is the unit load, and it is at a distance x from A. Now if I do summation of moment about g equal to 0, what I will get, VA I will get as L minus x by L into 1. ठीक है? This you know how you will get this, L minus x by L. What is the total length? Total length is 4, 4, 4, 4. How many times? 6 times. So 6 4s are 24. 24 minus x divided by 24. This is the value of vertical reaction at A. Okay. Now, I will split this question in two parts. First part will be when this load is in portion AC and when this load is in portion DG. Okay, so when load is from here to here, then I will take first case, and when load is from D to G, then I will take second case. Okay, so for first case, just a minute. Okay, so I'll take two cases. Case 1, x is between 0 to 8 meter. Okay, and to calculate the force in member CD, what I will do, summation of moment about j equal to 0 for this portion. Okay, I will forget about this portion now. Okay, so for in this portion I'll do summation of moment about j equal to 0. I have cut this section. Okay, I have cut this section. I'll take this part only. So summation of moment about joint j is equal to 0. Summation mj is equal to 0. Now, because of VA, how much moment is coming? Because of VA, we'll be getting VA into, this is the perpendicular distance. So 4, 4, 4, 12 meter. So VA into 4 meter, VA into 12 meter minus 1 unit load into. So this unit load will be giving moment in anti-clockwise direction. So from this, the distance will be, this whole was 12, 12 minus x, this will be the distance. So it will be 12 minus x. And moment because of force in member CD. So let us take this as tensile. This is FCD. So FCD into perpendicular distance is 3. So minus, this is also anti-clockwise. So minus FCD into 3. Minus FCD into 3 will be equal to 0. Okay. So what is the value of VA? VA we have already calculated, 24 minus x by 24. So we'll put 24 minus x by 24 into 12 minus 12 plus x minus FCD into 3 equal to 0. So 12 and 24 will be cancelled out. Here we will get 12 minus x by 2 minus 12 plus x minus FCD into 3 equal to 0. So here we will see 12 and 12 are getting cancelled out. X minus x by 2 will be x by 2. This will be equal to FCD into 3. FCD into 3. So that means FCD will be coming out to be x by 6. FCD will be equal to x by 6. So this is the value of FCD. When case 1, when load is from A to C, when load is moving from A to C, in that case FCD is depending on x and the variation is linear, it will be x by 6. Now if x equal to 0, then FCD will be equal to 0. X equal to 0. When x is 0, that means load is acting here. When load is acting here, there will be no force in CD member. And when load is moving and coming up to the point C, when load is acting at point C, then value of x will be, x is equal to 8 meter. So x equal to 8 meter, FCD will be equal to 8 by 6. That means it will be 4 by 3. 4 by 3. So these are the critical values. Okay, critical values in case 1. Now let's move on to case 2. Let's move on to case 2. In case 2, variation of x will be moving in this region from D to G. So at D, x will be equal to 12 meter. So from 12 meter to 24 meter. So x will lie between 12 meter and 24 meter. X will vary from 12 meter to 24 meter. Again, summation of mj is equal to 0. Summation of mj equal to 0. Now, at this joint j, now this load has come up to this point. Okay, so here in this case, moment will be because of VA and FCD only. Moment will be because of VA and FCD. So moment because of VA will be VA into 12. So that means this equation, from this equation, this part will be gone, remaining part will be there. Okay, so VA into 12 minus FCD into 3, FCD into 3 will be equal to 0. So VA is how much? 24 minus X by 24 into 4 is equal to FCD. So 4, 6, 24. So FCD will be equal to 24 by 6. 6 4s are 24. So 4 minus X by 6. This will be the variation of FCD. Now, X is varying from 12 to 24. So at X equal to 12. So when is X is 12, then this value will come out to be 4 minus 12 by 6, yani 4 minus 2. So FCD will be equal to 2, and at X equal to 24, FCD will be equal to 0. FCD will be 0. Okay. So now we can draw the influence line diagram. Okay. Now we can draw influence line diagram. So VA will be equal to, let me write again, 24 minus X by 24. So ILD will be somewhat like this. At C, see, if X equal to 0, FCD was 0. At X equal to 0, FCD was 0. At X equal to 8, FCD was 4 by 3. At X equal to 8, FCD was 4 by 3. So let us say this value is 4 by 3, and here it is 2, and here it is again 0. If we join all these points by straight lines, we will get variation something like this. You will get this variation. This value will be 2. Okay, this ordinate will be 2. This will be 4 by 3. Here it will be 2 by 3, and same here. This will be 4 by 3. This will be 2 by 3. Okay, so this will be the influence line diagram for force in member CD. Is it clear? Clear? So this is the answer, correct answer. So question 2 is done. Let's move on to question number 3. Let's remove this slide. Okay, let's move on to question number 3. Try this question. So this support is hinged. This is hinged. Joint A, this is hinged. This support is also hinged. Here on this part of the frame, we are having UDL 8 kilonewton per meter. So UDL acting is 8 kilonewton per meter. This length is 6 meter. This length is 5 meter. Here joint B is rigid. Joint B, this is rigid joint. Okay, so angle before and angle after between these two will be same. It will rotate like this. Okay, so try to calculate bending moment at B. How will calculate bending moment at B? I'll give you 2 minutes for this question. Any progress? Making any progress, or shall I start? Shall I solve this? Okay, so let me solve this question. So what we are going to do, let us employ, which method do you want? Moment distribution method or slope deflection method, or both? Moment distribution method, slope deflection method, or both? Let us first try with moment distribution method. Okay, let us first try with moment distribution method. So we are having, first we have to calculate distribution factors. Okay, so we are having, let us say this is joint, then member, then stiffness, then total stiffness, and then distribution factors. Okay, so joint, we are having joint B. At joint B we are having member BA and BC. So member BA and BC. Stiffness of member BA, here far end is hinged, so when far end is hinged we are having stiffness as 3 EI by L. So 3 EI divided by, what is the length? Length is 5 meter, and here also this end is also hinged, so again 3 EI by L, so it will be 3 EI by 6 or EI by 2. We can write EI by 2, 3 EI by 6 or EI by 2 will be same. So if I add them both, what I will get? 3 by 5 plus 1 by 2, I'll get 11 by 10. 11 EI by 10. Okay, so distribution factor will be stiffness divided by total stiffness. So 3 by 5 into 10 by 11, I will be getting 6 by 11. I will be getting here distribution factor 6 by 11, and here I will be getting 5 by 11. So distribution factors, is there any problem in distribution factor? Distribution factor is clear. Okay, so now we have got distribution factor. What we will do, I will draw fixed end moments. I'll find fixed end moments. Okay, so MF AB is equal to MF BA is equal to 0. Fixed end moments in AB and BA are 0 as there is no loading. Okay, fixed end moment in BC will be equal to minus WL square by 12. So it will be equal to minus 8 into length is 6 square by 12. 8 3 is 24, minus 24 kilonewton meter, and MF CB will be equal to plus 24 kilonewton meter. So this fixed end moments also I have found out. Now let us draw the distribution table. So moment distribution table I will draw. So here I will write joints A, B, C. In next line I will write members AB, BA, BC, BB. Distribution factors, no distribution factor, no distribution factor. BA is having 6 by 11, 6 by 11, and BC is having 5 by 11. These are the distribution factors. Now let us write down fixed end moments. So here fixed end moments are 0, 0. Here fixed end moment is minus 24. Here fixed end moment is plus 24. Now fixed end moments. Now what we have to do? Balancing moments. Okay, first we have to balance. How to get a GF? Clear the examination, you will get a GF. Okay, then after that what I have to do? I have to balancing moments. Okay, I have to apply balancing moment. So balancing moment, here joint C joint is what? Hinge joint. So here there should be 0 moment. So for 0 moment, balancing moment should be minus 24. Here it is minus 24. Okay, so unbalanced moment is 24. Unbalanced moment is 24 plus 20. So I'll have to apply balancing moment plus 24. Okay, plus 24. So 24 into 6 by 11 will be 13.09. So this will be plus 13.09. Here 5 by 11, it will be 10.91 plus 10.91. Okay, so these are the balancing moments. Balancing moments. Now carryover moments. Here I will transfer carryover moment. How much? Minus 12. Okay, carryover moment. Here I will transfer minus 12. Here carryover moments will not go. Again I have to distribute 12. So 12 into 6 by 11, that will be 6.54. It will be plus 6.54, and here 5 by 11, it will be plus 5.45. 5.45. So these are the balancing moments, again carryover moments, then balancing moments, and now we will add them all. We'll add them. Okay, so here we will get 0. Here we will get 13.09 plus 6.54. So 13.09 plus 6.54, we will get 19.63 plus 19.63. Here we will get minus 24 plus 10.91 minus 12 plus 5.45. We will get minus 19.64. Minus 19.64, and this will be 0. Okay, so bending moment at B. How much will be the bending moment at B? Bending moment at B will be, you can report 19.63 or 19.64. Okay, this much approximation can be there. So bending moment at B will be equal to 19.64 kilonewton meter. Okay, this will be the correct answer. Now, do you want to solve it by slope deflection method also? First, you tell me, is this clear? How we have solved by moment distribution method? Moment distribution method is clear. Let us now solve it by slope deflection method also. Okay, so just a minute, let me solve it by slope deflection method also. Slope deflection method. For slope deflection method, I am okay. So distribution factors, no role of distribution factors in slope deflection method. Okay, so fixed end moments we know. Fixed end moments also we know. What are the fixed end moments? M bar AB will be equal to M bar BA will be equal to 0. M bar BC will be equal to minus 24 kilonewton meter. M bar CB will be equal to plus 24 kilonewton meter. Now, if I want to write slope deflection equation, so what will be the slope deflection equation? MBA. First I will write for MBA. MBA will be equal to M bar BA plus 2EI. I will not write 2EI by L. Why I will not write 2EI by L? I will use modified slope deflection equation. I will write 3EI by L, and I will write theta B. Theta B. So M bar BA will be equal to 0 plus 3EI divided by length is 5 meter theta B. Okay, so this will be MBA. Now MBC will be equal to M bar BC. You know modified slope deflection equation. Modified slope deflection MBA we have found out. Now MBC will be equal to M bar BC plus 3EI by L. Now here L will be 6 and it will be theta B. Okay, so MBC will be equal to M bar BC. M bar BC is minus 24 plus EI theta B by 2. This will be MBC. Okay, now at this joint, equilibrium equation we will write. What will be the equilibrium equation? Summation of moments at point B will be equal to 0. So summation of moments at point B. So at point B we are getting two moments, MBA and MBC, right? So we will write equilibrium equation, summation of moment at point B will be equal to 0. So MBA plus MBC will be equal to 0. What will be the value of MBA? MBA is 3 EI theta B by 5. 3 EI theta B by 5 plus MBC is minus 24. So MBC is minus 24 plus EI theta B by 2. EI theta B by 2 will be equal to 0. Okay, so 3 by 5 plus half. 3 by 5 plus half, that will be 11 by 10. 11 EI theta B by 10 will be equal to 24. So theta B will be equal to 240 upon 11 EI. This will be the value of theta B. Now I have found out theta B. Can I find out MBA from here? Theta B I have got from equilibrium equation. Now that value of theta B I can put either in this equation or in this equation. It will be easy if I put in this equation. So let me find out MBA. So what will be the value of MBA? MBA will be equal to 3 EI theta B by 5. 3 EI theta B by 5. So 3 EI by 5 into theta B is 240 upon 11 EI. 240 upon 11 EI. 5 6 are 24, so it will be, sorry, 5 6 are 30. What I'm doing? 240. This will be 48. 48. So 3 into 48 by 11. MBA 3 into 48 by 11. 13.09. If I calculate from here, minus 24 plus EI theta B by 2. So EI theta B by 2, 240 divided by 2 divided by 11 minus 24, 13.09. MBC. Three by 6 minus 24. Leave it with slope deflection method. Better is moment distribution method. Okay, so we have calculated by moment distribution method. Let's move on to the next question. Question number 4. 3 wheel loads 10 ton, 26 ton and 24 ton spaced 2 meter apart roll on a girder from left to right with the 10 ton load leading. The girder has a span of 20 meter. For the condition of maximum bending moment at section 8 meter from the left end, we have to find out what should be the position of the load. Okay, so try solving it. So are you able to solve it? Let us try this question. Okay. So three wheel loads are there: 10 ton, 26 ton, and 24 ton. Okay, these are the three wheel loads. They are spaced 2 meter apart. They roll on a girder from left to right. So they are rolling from left to right with the 10-ton load leading. That means the sequence is just opposite. They are moving in this direction. They are moving like this. They are moving in this direction. Okay, 10-ton load is leading. So three loads are there and they are spaced equally. Okay, the distance between all of them is 2 meter, 2 meter, 2 meter. Okay, 2 meter apart they are. Okay, so 10-ton load is leading. 10-ton load will be here. 26-ton load will be next to the 10-ton load, and 24-ton will be the last load. Okay, now this is the sequence. Okay, this is the sequence. Now for the condition of maximum bending moment at a section 8 meter from the left end, so what is the span? What is the span? Span is 20 meter. Okay, so let us say this is the girder. This is the girder. Span of girder is 20 meter. 20 meter is the span of the girder. Okay, from left end at 8 meter distance. So this distance will be 8 meter. This distance will be 12 meter. Somewhere here. Okay, somewhere here, somewhat away from the midpoint. So this is 8 meter. This is 12 meter. At this location, what will be the condition of maximum bending moment? What will be the condition of maximum bending moment? So condition of maximum bending moment is such, maximum bending moment will always arise when one of the loads is at the section. Okay, one of the load must be at the section. Now which load should be at the section? The load that should be at the section should be heavy of the load. Whichever load is the heavy load, that should be at the section. And if the middle load is heaviest, then that load should be at the section. So the condition should be like this, that at this location 26 ton load should be here. Okay, 10 ton load should be here, 10 ton, and 24 ton load should be here. 24 ton load should be here like this. Okay, so 26 ton load should be placed at the section. This heaviest load is at the middle, so this will be the condition when 26 ton load should be at the middle. Okay, clear? Just by examination we can consider it. Okay, just by examination we can tell this. Now next question, here different structures are given and degree of static indeterminacy is also given. Now you have to find out for which structure correct answer is given. Okay, for all the structures first examine which type of structure is there, and then you notice what is the degree of indeterminacy. If that degree of static indeterminacy is correct, that option will be right. So this is MSQ type of question. More than one answers can be correct. Okay, so try solving this question in 1 minute. What should be the answer? What should be the answer? Just answer fast. Okay, let us solve it. So here this end is also fixed, this end is also fixed, it will act like a fixed beam although it is an arch. But if we consider static indeterminacy, there will be no difference between the fixed beam and the fixed arch. Degree of static indeterminacy will be 3, so this one will be the correct answer. If you want that I should solve this by formula, however it is not required, okay, it is very easy. So degree of static indeterminacy will be 3, so A will be the correct answer. Now let's move on to the next question. So we can, by short trick method we can convert into cantilever. Okay, this cantilever, in this cantilever beam, degree of static indeterminacy is what? 0. Degree of static indeterminacy is 0. If I add this support, that means I am adding two reactions. I'm adding two reactions if I'm adding this support. So that means degree of static indeterminacy is what? Has now become 2. Okay, if I'm adding this support, again degree of static indeterminacy will increase by 2 amount. Okay, this will offer also 2 reactions, this support will also offer. So 2 plus 2, it will be 4, and again 2 more reactions will be offered. So that means total degree of static indeterminacy will be 6 in this case. But if I provide one hinge, then I will get one additional equilibrium equations. So degree of static indeterminacy will reduce by 2. That means because of these supports, my degree of static indeterminacy has gone up to 6, but because of this hinge it will reduce by 1, so degree of static indeterminacy will be 5. So that means this option is also correct one. Okay, clear? Now in this case, if I consider is by method of joints, so not method of joint, sorry, cut section. Okay, open tree structure if I make, so I have to cut 2 sections. Okay, so degree of static indeterminacy will be equal to 3c minus r dash. Okay, 3c. So how many cuts are there? There are 2 cuts. Okay, so 3 into 2 minus r dash. Now what is the meaning of r dash? R dash means how many support restraints I have to add so that these becomes fixed joint. So in this, 2 reactions are already present. If I add one more reaction, then that will become fixed joint. And here also 2 reactions are already there. If I add one more reaction, then it will be, this will also become fixed joint. So here I have to add one reaction, here I have to add one reaction. So 2 reactions in total I have to add. So 3 2s are 6 minus 2, it will be 4. So this will be the degree of static indeterminacy, 4. And similarly, this will also have same structure. So this will also have degree of static indeterminacy 4. So all the options are correct here. A, B, C, D, all are correct. Okay, so this is the correct answer. Let's move on to next question. Try to find out bending moment at A. Fixed end moment MA. You have to find out. Okay, so take 2 minutes for this question. Okay, let us solve this question. So this is statically determinate structure. Statically determinate structure, how I can find out? See, this reaction I don't know. Okay, and most probably this is the support reaction. So when there is support reaction, there is one hinge. So if I add one support reaction in the cantilever beam is always statically determinate. In this statically determinate cantilever beam, I add one support reaction. So because of this support reaction, degree of static indeterminacy will increase by 1. Degree of static indeterminacy increases by 1 because of this. And because of this hinge, what will happen? Degree of static indeterminacy again reduces to 0. So this will become statically determinate. Now, since this is statically determinate structure, we can analyze it by equilibrium equations alone. So we'll apply equilibrium equations. Let us first find out what is the reaction at C. Let us say this is RC. If we want to find out reaction at C, at hinge, this point, bending moment is 0. So let us calculate bending moment at B from right side. So bending moment MB is equal to 0. So this we are calculating from right, or if we can say summation of moment at B equal to 0 from right, that is also true. So bending moment will be 0. So what will be the bending moment? Bending moment will be because of this 20 kilonewton and RC both. Okay, so because of that 20 kilonewton, distance of 20 kilonewton is how much? 6 meters. So 20 into 6, 20 into 6, and this is taking it clockwise. So let us take clockwise positive, and RC will be taking it anti-clockwise. So minus RC into the perpendicular distance is 4 meter. So that will be equal to 0. So RC will come out to be 4 5s are 25. 5 6 are 30. So RC is equal to 30 kilonewton. RC is 30 kilonewton. Very good. We have found out the RC. Congratulations. Now, next part. RC we have found out 30 kilonewton. Half the question is done. Now we have to calculate bending moment, fixed end moment at A. So for fixed end moment at A, summation of all the moments about A will be equal to 0. So what are the moments about A? About A, what all moments will be there? Moment will be because of this 20 kilonewton, because of this RC, and because of this MA. So because of this this 20 kilonewton moment will be 2 plus 4 plus 4, that means 10. 20 into 10, so 20 into 10. Because of this RC's distance is how much? 8. So RC value is 30 kilonewton, 8 is the distance. So, and it is taking anti-clockwise, so minus RC value is 30 into 8, and this is also anti-clockwise, so minus MA. Here they have shown the direction anti-clockwise, otherwise we can take clockwise or anti-clockwise, whatever. Here they have shown the direction, so let us take it minus MA will be equal to 0. So 200 minus 3 8 is 24. 240 minus MA will be equal to 0. So minus 240 minus MA is equal to 0. That means MA is equal to minus 40 kilonewton meter. So the fixed end moment shown in the given figure is minus 40 kilonewton meter. Correct answer will be this. So question 6 is done. Let's move on to the next question. Okay, this is very easy question. I think all of you will be able to do it. Very easy question. So try it yourself. I will give you 1 minute only. For this question, I will give you 1 minute. And yes, this is also 10 kilonewton. Both the loads are 10 kilonewton. Okay, so let us solve this. See, the loading is symmetrical and structure looks like it is symmetrical, but this structure is not symmetrical. If you look at the loading, the support conditions, if you look at the support condition, this is fixed support and this is hinge support. Okay, so everything else is symmetrical. Everything else is symmetrical except for this support condition. So this is fixed support and this is hinge support. So if I check the flexural rigidity of this member and if I check the flexural rigidity of this member, so at this joint flexural rigidity of this member will be 4 EI by L and here flexural rigidity will be 3 EI by L. So this is having more flexural rigidity, this will be more rigid, and this will be having less flexural rigidity. So in case where the loading is symmetrical, structure seems to be symmetrical, but it will sway in the direction where the flexural rigidity is less. Okay, so it will sway in this direction. So what happens is this member will appear to be weaker than this member because this is having more flexural rigidity, this is having less flexural rigidity, so it will sway like this. Okay, so it will sway towards the right. Correct answer will be option B. Okay, let's move on to the next question. Try this question. So distribution factors at joint B. At joint B, we have to find out the distribution factors. So at joint B, there will be two members BA and BC. Here the lengths are different. So at joint B, if we look at the far end, if we look at this member BA, if we look at this member BA, so what will happen at member BA? What will happen? So here, let me write down joint, then member, then stiffness, then total stiffness or summation of K, and then distribution factors. So at joint B, there are two members BA and BC. BA, BC. Stiffness is how much? Stiffness is here. Far end is fixed, so it will be 4 EI by L. So 4 EI by 4 is equal to EI. Here far end is hinged. Okay, so 3 EI by L. Length is here 3 meter, so 3 EI by 3 it will be equal to EI. So total stiffness is 2 EI and distribution factors will be half and half. Okay, so 0.5 and 0.5. Very easy question. 0.5 and 0.5. Correct answer will be option C. So question 8 done. Let's move on to the next question. Question number 9. Now see, in this you have to just grab one concept, that EI is 0. Flexural rigidity is 0. So that means at joint B and at joint C, it will not offer any resistance against the rotation of these joints. Okay. This member, BC member, is not going to offer any resistance for rotation. So if this member is rotating like this, will it offer any resistance for rotation? No. Okay. So the rotation will be just like if there was no member. If the BC member was absent, okay. So if BC member was absent, there would be rotation, just like it is a freely supported column, here fixed end, and here there is no support at all. Okay. So it would be like this. Okay, whatever rotation will happen in this column, same rotation will happen in this column, but only flexural rigidity is 0. Axial rigidity is not 0. That means if this member is moving like this, it is deflecting like this. Okay, here nothing is said about axial rigidity. So if this deflection is delta, then same deflection will be delta here also. Same deflection delta. And if same deflection is delta, and here flexural rotation is just like a free column, okay, then this delta will be equal to this delta, and this delta will be same. Okay, then both these columns will equally resist this load P. Okay, whatever load P is coming, both these columns will resist this load. Okay, so the question is framed like that, it will confuse you. Okay, how it is confusing you? It is confusing you by saying that AI is equal to 0. So but axial rigidity is not 0. Axially nothing is said, so we have to take it as axially rigid. Okay, so axially rigid, but flexurally it is um, 100% flexible, we can say. Okay, flexural rigidity is 0 and axial rigidity is infinite. However, in reality, we will not find any such member. In reality, this type of member will not exist. Okay, but anyways, now if I want to find out what is the deflection, so I can find it on two ways. I can say that I will take this member alone and I can say that this member is resisting load P by 2 and P by 2 will be resisted by this column. Okay, so this column will resist load P by 2. Here EI is same. That is why they both will resist P by 2 and P by 2. Okay, so because of this P by 2, what will be the deflection? Horizontal displacement. What will be the horizontal displacement? Delta horizontal displacement, same here, same here. Okay, so delta will be equal to PL cube upon 3 EI. That is the formula. But instead of P, we will take P by 2 here. So it will be PL cube upon 6 EI. So PL cube, and here in place of L, we will take H. Okay, in place of L, we will take H. So PH cube upon 6 EI, correct answer will be option D. So question 9, correct answer is D. Let's move on to the next question. Question number 10. Question number 10. This is also very easy question. You will be able to solve it in minutes. Okay, so let us solve this question. Okay, so here in the pin jointed truss as shown above, the horizontal deflection of roller support will be the sum of the deformation in members. So this is the support. If this support is moving, in which direction this support will move? This joint will move in which direction? Either it will move exactly in this direction, exactly horizontal in this direction, or exactly horizontal in this direction. And these two members are also horizontal. If this is compressing here, okay, it is pressing here. So deflection of this plus deflection of this will be equal to movement of this. And if it is going there, then also deflection, extension of this plus extension of this will be equal to movement of this joint. Okay, so deflection of joint F will be equal to change in length in member AG plus change in length in member GF. Okay, so AG and GF, sum of deformation in members AG and GF. Okay, so correct answer will be option C. So these are the 10 questions for today's session. I hope you liked these sessions, and subscribe and continue watching for more such sessions, more such useful sessions. Thank you, dear students. See you in the next session. Okay.